Continuing in 10.4, we're going to example 2. Apply the integral test. Determine whether the following series converge. Okay, so the summation k equals 1 to infinity of k over k squared plus 1. So we are going to look at this and say the function that I want to deal with would be x over x squared plus 1. It is positive for x is greater than or equal to 1. And they are decreasing. If you start putting in numbers, you'll see that it is decreasing. And so now we're going to look at the integral. And you could also check that by taking the derivative, using the quotient rule on it, and if it comes out the derivative is less than 0, that implies the function is decreasing. So you could do it that way. But you could also look at the graph and convince yourself it's decreasing. And so we are going to integrate from 1 to infinity x over x squared plus 1 dx. My u would be the x squared plus 1. My du would be the 2x dx, which means I need to stick a 2 in and a 1/2 out. And remember, you're going to be taking the limit of this because you're going to infinity. So we're going to rewrite this as the limit, and I'll put the 1/2 out in front of it. As b goes to infinity, 1 to b, this would be 1 over u du, which turns into natural log of u. So it's the natural log of x squared plus 1 from 1 to b, which would be 1/2 the limit as b goes to infinity of the natural log of b squared plus 1 minus the natural log of 2. And as b goes to infinity, this piece right here very slowly is approaching infinity, so it makes no difference that you have a minus natural log of 2 or that you're taking a half. It goes to infinity, so the integral goes to infinity, which means it diverges. The series also diverges. And I would say by the integral test. Part B. Part B says the summation k equals 3 to infinity 1 over the square root of 2k minus 5. And notice it starts at 3 because it gets rid of the problem with the increasing and decreasing. So if I use anything higher than 3, if I use anything lower than 3, I'm going to get a negative underneath the square root, and they didn't want that to happen. So if I start putting in numbers in 3 or greater, it is decreasing, it is continuous. So we meet the requirements, because requirements for the integral test that says that I must be continuous, positive, and decreasing, and it is positive. So I can set up my integral from 3 to infinity of 1 over the square root of 2, I'm going to call it x now, x minus 5 dx. Okay, this is a u du. U would be 2x minus 5, du would be 2 dx. So in looking at this, I need to stick a 2 in and a 1/2 out, just like the first one. So now I have my 1/2 It's interesting, the book has an error. 1/2 the limit as b goes to infinity from 3 to b, and this is u to the negative 1/2 du. They didn't put the 2 in, they totally forgot about it. Doesn't make a difference in this case, but that's kind of odd. 1/2 the limit as b goes to infinity, raise the power, flip it in front, and it is going to cancel for us. So it's going to become u to the positive 1/2 with a 2 in front. They just didn't write it down, so maybe it wasn't a mistake. Maybe they just jumped right through the hoops and didn't put in all the steps. The 1/2 and the 2 will cancel. So now I'm taking the limit as b goes to infinity of the square root of b minus the square root of 3. The square root of b part, that's going to go to infinity. So it makes no difference that I'm subtracting a square root of 3. So this is going to be infinity, so series diverges. by the integral test. And is it, yes, there's a part C. Okay, part C, summation k equals 0 to infinity of 1 over k squared plus 4. All right, it would be decreasing. It will always be positive. It is continuous from 0 to infinity. So I'm setting up my integral again. 0 to infinity, 1 over x squared plus 4. That's an arctan. Okay, so I have the limit as b goes to infinity, integral 0 to b. In this case, my u is x, my a is 2, and so my du is just dx. I'm not missing anything. So this is going to be 1 over u squared plus a squared, which turns into the limit as b goes to infinity of 1 over a, so 1 over 2 arctan of x over 2 from 0 to b. Put the 1/2 in front, limit as b goes to infinity. This is going to be the arctan of b over 2 minus the arctan of 0. The arctan of b over 2, as b goes to infinity, remember that the tangent curve looks like this, and right here is pi over 2, and right here is negative pi over 2. And the question is, what is the angle when the tangent heads to infinity? It's pi over 2. And the tangent of 0 is 0, and so I have 1/2 times pi over 2, which gives me pi over 4. So I can say, because the integral is finite, it converges. So I can say the series converges by the integral test, but not, I won't put it in parentheses like they did. Remember that the answer does not give you what it reduces to. The next thing we're going to talk about is the p-series.